In more than a decade of discovery, NASA's Hubble Space Telescope has taken humanity where it has never gone before. Recently, Hubble discovered the largest and brightest star-forming region ever seen, helped find the oldest planet in the galaxy, took us back to the cosmic dark ages, and surveyed baby galaxies in the ancient universe. Hubble continues to lead humanity's quest to understand the cosmos. In August 2003, Mars came closer to Earth than at any other time in the last 60,000 years. The Hubble Space Telescope used the opportunity to capture the best ever image of the red planet from Earth. The image became Hubble's most popular observation of the year, as millions of people around the world watched Hubble watch Mars. America's great observatory took people from all over Earth a little closer to our neighbor planet. What happens if a planet gets too close to its parent star? If it's a gas giant like Jupiter, the star's intense heat will boil the planet's atmosphere away. Hubble detected a planet that orbits so close to its parent star that its atmosphere is evaporating away into space. Eventually, enough of it will boil off to leave only a scorched solid core. Hubble also confirmed the discovery of the oldest known planet in our Milky Way galaxy. If it's as old as astronomers believe, at 13 billion years, it's nearly 3 times as old as our own Earth. It's almost as old as a planet can be.
What we think we found is an example of the first generation of planets formed in the universe. We think this planet formed with its star 12.7, 13 billion years ago, when the galaxy was very young, just in the process of forming, and it formed with the very earliest generations of stars that formed in our galaxy, much, much earlier than the Sun.
This identification is a stunning revelation. The idea that there is now evidence for a planet which was formed roughly 1 billion years after the Big Bang, 13 billion years ago, is just absolutely unprecedented. All of the roughly 100-odd extrasolar planets that we know about today are in orbit around stars that are basically in the solar neighborhood. They are presumably stars that are no older, particularly, than our own Sun. But in this case, we have a star where we presumably could have formed not only a gas giant planet, but perhaps also a habitable planet where life could have arisen and died out long ago, well before we came along to the galactic party.
The planet is in an ancient globular star cluster and is part of a system that includes a fast-spinning pulsar and a white dwarf star. Unlike previously discovered planets outside our solar system, which are all in our interstellar neighborhood, this planet is on the other side of the Milky Way galaxy. Its existence and age imply that planets formed very early after the Big Bang and may be far more abundant throughout the universe than previously thought. Glowing ghosts in the sky, dying embers of burnt-out stars, or nurseries where new stars are born. Like no other observatory, the Hubble Space Telescope shows us the secret lives of stars, from cradle to grave. In early 2002, a distant star in an obscure constellation suddenly flared up to become 600,000 times brighter than our Sun. It has since faded, but Hubble has been watching its light echo off the gaseous clouds surrounding it. The stellar blaze is lighting up the gas shells surrounding the star, which were ejected in earlier eruptions. The light from the recent outburst travels to the shells and is reflected to Earth. This indirect path means the direct light arrives months earlier than the reflected light. Hubble is using the echo to create a unique three-dimensional probe of the star's environment. Stars are born in colossal cauldrons of gas and dust. Hubble recently imaged the star-forming nebula M17, showing us a blaze of baby stars born in shock waves created by older stars dying in gigantic explosions. The Helix Nebula is one of the largest in the stellar neighborhood. It also formed in the death throes of a star, similar to our own sun.
When stars like our sun, or slightly more massive than our sun, die, they lose lots of their outer envelope in a massive stellar wind. And this massive stellar wind enshrouds the star in a dusty molecular rich cocoon.